In an era where the boundless edges of technology blend seamlessly with daily life, robotics stands firmly at the forefront, merging the once divergent paths of science fiction and practical engineering. As we venture deeper into the 21st century, robots continue to evolve from mere novelties to integral components of modern society, reshaping industries, augmenting human capabilities, and constantly challenging our perceptions of what is possible. This essay delves into the vivacious realm of robotics, uncovering its expansive definitions, diverse types, pivotal applications, and the burgeoning technologies steering its evolution. What is robotics? Robotics, a term that once conjured images of clunky, futuristic automatons in the popular imagination, nowadays refers to a wide-ranging field that encompasses the design, creation, operation, and use of robots. Broadly defined, robots are programmable machines that are capable of carrying out a complex series of actions autonomously or semi-autonomously. However, the true essence of robotics stretches beyond mere mechanical functionalities to include aspects of artificial intelligence, machine learning, and even ethical programming. The four main types of robotics. Robotics can be classified into four primary types, each serving distinct purposes and equipped with unique capabilities that cater to various needs and environments. Industrial robots. These robots are the stalwarts of the manufacturing industry, performing tasks that require precision and endurance beyond human capabilities. They are typically found in assembly lines for automating tasks like welding, painting, and packaging. Service robots. Service robots are designed to assist humans, generally outside industrial applications. They include surgical robots that perform delicate operations and customer service robots that manage information flow in business settings. Mobile robots. Mobile robots are capable of navigating various environments, from the structured pathways of warehouses to the chaotic streets of urban cities. They can be used for deliveries, surveillance, and even planetary exploration. Specialized robots. This category includes robots designed for specific tasks that don't fall into the other categories. Examples include underwater robots for oceanographic research and humanoid robots specifically designed for research and educational purposes. Application across industries. Robotics has permeated numerous fields, dramatically transforming workflows and enhancing productivity and safety. In medicine, robots are employed not only for complex surgeries, but also in rehabilitation and patient care. In agriculture, autonomous tractors and harvesting robots are changing the landscape of traditional farming, making it more efficient and less labor-intensive. In the automotive industry, robotics has revolutionized production lines, increasing the speed and precision of vehicle assembly and testing. Meanwhile, in the world of entertainment, robotics brings to life realistic animatronics for movies and theme parks. In logistics, drones and autonomous vehicles simplify inventory management and goods transportation, profoundly altering supply chain dynamics. The propulsion of robotics into the future is largely fueled by advancements in several key technologies. Artificial intelligence and machine learning algorithms provide robots with the ability to learn from their environments and adapt to new tasks. Sensor technology and computer vision enable robots to perceive their surroundings more accurately, making decisions and performing tasks with greater autonomy and precision. Robotics is also deeply intertwined with advancements in materials science, which lead to lighter, stronger, and more energy-efficient designs. There are several robots that exemplify the pinnacle of current robotic capabilities. The Da Vinci surgical system allows surgeons to perform delicate operations with unmatched precision. Boston Dynamics Atlas robot showcases extraordinary balance and mobility, highlighting substantial progress in humanoid robotics. In the consumer market, robots like Roomba have become household staples, taking over mundane tasks like vacuuming. For those keen on keeping pace with the rapidly evolving field of robotics, there are several resources. Academic journals, industry conferences, and various online platforms offer insights into the latest research and innovations. Websites like IEE, Spectrum, and RoboHub provide timely articles and podcasts that cater to both novices and experts in the field. As robotics continues to grow, so does the demand for skilled professionals capable of designing, programming, and managing robotic systems. Key skills that are currently in demand include software development, systems engineering, and data analysis, among others. The future of robotics not only promises ongoing advancement in technology and applications, but also offers a wide array of career opportunities. The sector is likely to see significant growth in areas such as AI integration, autonomous transportation, and personalized robotic solutions for healthcare. As industries continue to adopt robotic solutions, the need for experts in robotics will only expand, providing a robust career path for those equipped with the necessary skills. By comprehensively understanding the vast terrain of robotics, one grasps not only the mechanics, but also the far-reaching impacts and potentials of this dynamic field. From revolutionizing industries to enhancing daily life, the future of robotics is not just about technology, it's about shaping a new dimension of human experience.